favorite students.
I have a very important job today to model and explain each MCAS question so that everyone understands. You have an important job too, to work and to try with the effort I know you have. I'm sure that with time, patience, and hard work, you will get better at mathematics.
Question 3 says, triangle LMN is similar to triangle PQR. The triangles and some of their dimensions are shown in this diagram. Based on the dimensions in the diagram, what is the value of Z? And the options are A, 2.7 centimeters, B, 4.8 centimeters, C, 5.8 centimeters, and D, 8.3 centimeters. So before we go into anything about similar triangles, I think it's important to remind everyone that the MCAS is typically taken on the computer. So we should all get in the habit of copying important language and drawing the figures or diagrams we may see. I'm going to start by drawing the smaller triangle first. I'm going to make sure to label all the parts I see. Okay, we have right triangle PQR, with the length of the hypotenuse being 5.6 centimeters. The hypotenuse is the longest side of the right triangle, and notice that it's always across from the right angle. The other side length we know is the height, which is given as 2.9 centimeters in the smaller triangle. Next, I'm going to draw the larger triangle right next to the smaller one. Even though we can't draw the triangles perfectly, obviously, they will be much easier to compare side by side. So the larger triangle is right triangle LMN. We are given the length of the hypotenuse for this one as well. It is 11.2 centimeters. What we don't know about the side length of the larger triangle is the height, which is labeled Z. So that's the value we need to find. So just like in non-math life, the word similar means that any two shapes have things in common but are not exactly the same. Specific to math, similar shapes are the same exact shape. In this case, there are two right triangles and have the same angle measures. However, the side lengths are different. As we can see, one triangle is smaller than the other. The side lengths of similar figures do have something in common, though. They are proportional. That means the sides of the smaller shape fit into the sides of the larger shape a specific number of times. That number does not necessarily have to be a whole number. Remember, when comparing shapes, to find the corresponding side. The corresponding side is in the same place on both figures, which is why we drew them side by side, making it easier to compare them. Okay? So in order to solve for an unknown side, you can create a ratio for each triangle using the side lengths. So if we do 5.6 centimeters as the hypotenuse of the smaller triangle, and compare it to 2.9 centimeters, the other side length, we would make a proportion that would be equivalent to side length 11.2, hypotenuse 11.2 centimeters, and then the unknown side Z. All right, so we have the two hypotenuses across from each other, and then we have the two heights across from each other, the Z being the unknown. Okay, if this setup is your preferred method, I have posted the entire process for you, how to solve for Z. However, looking back at our drawing, I would like to try a different method as we have decimals, which may be intimidating to some of us when multiplying and or dividing. I would like to use the corresponding hypotenuses. The corresponding sides we know both numbers for in order to see what the scale factor is. The scale factor is the number of times one proportional shape or side will fit into another. So, times question mark, how many times will 5.6 fit into 11.2? One of the reasons I drew the smaller shape first is because the unknown side is in the larger shape. The other reason is when you go from small to large, you multiply by the number 1 or larger. If you find the scale factor from the larger to the smaller shape, your number will be less than 1. So if we went in the opposite direction, we would be multiplying by a fraction, and that may be more challenging as some people do not really care for multiplying by fractions, okay? So we need to find out how many 5.6s fit into 11.2. To do that, we need to use units of 5.6. See, if we think of 5.6 on our number line, we know we just need to add 5.6 to itself until we get to 11.2. So this is 1 unit of 5.6 plus 5.6. And then we need to just keep that same value going on the number line until we get to 11.2. Remember, when you add decimals, the place value will not change, all right? So if we do 5.6 plus 5.6, that decimal stays in exactly the same spot. 6 plus 6 is 12. Put down the 2, carry the 1, bring down the decimal. 1 and 5 is 6, and 5 is 11. Ding, ding, ding. All right, so we see that it takes 2 units of plus 5.6 to get to 11.2. The scale factor is 2. And I'm going to reiterate, because it took 2 units of 5.6 to equal 11.2. Now that we know what the scale factor is, I'm going to write this huge in a different color, times 2, even though I'm covering up a little bit of our work, okay? We know that it will take 2 units of 2.9 to find the value of z, okay? Because, as you can see here, we're going from the smaller triangle, the ratio that's representative of the smaller triangle, to the ratio that's representative of the larger triangle. All right, so we know we're going to multiply by 2, also known as adding 2.9 to itself. Okay? So on our number line, we're going to go up to 2.9 plus 2.9 here, plus 2.9 one more time, and we get to the value of z. Okay? So let's line up our decimals again. 2.9 plus 2.9. 9 and 9 are 18. Carry the 1, bring down the decimal. 1 and 2 are 3, and 2 is 5. So we get 5.8. As we can see from the choices, our answer is C, 5.8. Okay? I hope you feel more comfortable with similar figures after solving this problem. Remember, there are often alternate approaches to a problem if it seems very challenging. See you soon.
I am so proud of everyone. We accomplished a lot today, and we all need a break. Please remember that wherever you are in your life or in the world, you have someone here who can help you with your mathematical journey. Thank you so much, and until we meet again.